So when you guys write your answers for these, what we were doing last week was writing your answers as ordered pairs. Well, in three variable systems, you write your answers in ordered triple. So X, Y, Z. I don't know that many of you guys have dealt with three-dimensional graphing before. We think about our y-axis and then our x-axis, and over here on this plane, the z-axis would actually extend vertically from the paper, so it'd come out, and you can imagine it going below also. But when we think about a point in 3 dimensions, it would be in space rather than on the paper. So when we're thinking about lines crossing in 2 dimensions, now we're looking at trying to find where 3 lines are crossing, so it's actually in space. If you want to look up in the very corner of the room, you can see that the 3 lines intersect in that one little point, in space. It's kind of a way to imagine what's happening here. We're trying to find where that's happening. So, an ordered triple is the way we'll express our answers. These problems can be very large, so you've got to make sure that you're keeping track of your work and that you're being clear in what you're doing. Definitely one of those things where if you make one little mistake, and it just follows you through, and you don't until the end that it's wrong. It's really hard to find those mistakes as you're reading back, especially if you're not clear in your work. Your work is not laid out in a way that it's easy for somebody else to come along and find, and read through. So I'm giving you guys some tips on how to keep track of things and kind of how to lay things out so it's not just a big mess. Okay, definitely with my second hour class, I think looking at a couple of those kids' tests, and then imagining them doing this work, I'm like, whew, it's gonna be a mess. So just I have those feelings about any of you all specifically, but just trying to be neat and orderly and clear in what each step you're doing is, so that if you make a mistake, that I can go back and see hopefully where it is. So, okay. So we're just going to start off with 5x plus y minus 3z equals -6. It's 2x plus 3y plus z equals 5. And -3x minus 2y plus 4z equals 3. So right off the bat, I'm just going to label each equation with a name, essentially, so we can just say equation 1, equation 2, equation 3, rather than having to say 5x plus y minus 3 equals -6. So this is just equation 1, this is equation 2, that's equation 3. Okay, so just purely naming them for ease's sake. Okay, 1, 2, and 3. So we have 3 equations, 3 variables. We end up knowing what x and y and z are in all of them. The process here really isn't any different than with 2 variables. There's more to it. And so you can eliminate, find ways to eliminate variables, or you can find ways to substitute variables out. Generally, with the 3 variable system, substitution is not a great way to go. Okay? Getting one of the variables by itself is often kind of difficult. Multiple times getting kind of difficult. So generally, elimination is the easiest path through these. Okay? So thinking along those lines, is there a way for me to eliminate a variable, but we have to eliminate it twice? So we want to take this system of 3 equations with 3 variables and turn it into a system of 2 equations with 2 variables. Basically, we want to find a way to rewrite this problem into the problems we were doing last Monday. Okay? So we have to find a way to get rid of x twice, or find a way to get rid of y twice, or find a way to get rid of z twice. And so looking at those x's and y's and z's, can I turn a 2 into a 3 or a 5 very easily? Not really, right? Getting those numbers to be the opposites is not going to be easy. When I look at that y, I see that 1 right there. And 1s are nice, because I can turn a 1 into a 3, or I can turn a 1 into a 2 really easily. Okay? And same thing here with the z, I can also turn this 1 into a 3, or I can turn that 1 into a 4 very easily. So I always key in on if I can find one that has a 1 in it, just like before, and saying, okay, that's going to be the easiest. Well, I have two ones, so really I kind of just pick my poison here. Say, do I want to get rid of y? Do I want to get rid of z? Doesn't really matter. They both can be pretty darn easy. So what do you want to do, Grant? Y or z?
Y.
Okay. So if we want to get rid of y, so I have to be able to do it two times, two different ways. Okay. So if I take that equation 1 and I multiply it by -3, I can cancel the y in those two. Okay. So I'm going to say what I want to do so that I remember what I was trying to do and that somebody else could come along and say, okay, here's what they did. So I want to take equation 1 and multiply it by -3. So -3 times equation 1. I'm going to add it to equation 2. Okay? So -3 times equation 1 plus equation 2. So as I go to do -3 times equation 1, I'd really suggest you guys are using your fingers to point, okay? Because it's so easy to grab the wrong thing. Okay? That's just what I call a transfer error. Grab the 2x instead of the 5x, but I want to multiply that by -3. So -15x. -3 times that would be -3y. -3 times that would be +9z. -3 times that would be +18. Last class I wrote -18 because I wasn't paying attention, and luckily one of the students caught that before we moved on. Now I want to bring equation 2 over without changing it. 2x plus 3y plus z equals 5. Double, triple check, because you don't want to make a transfer error and screw all this math up that we're about to do. Okay? Said I want to add those together, so I'm going to go and do that adding. Gives me -13x's, y's cancel. It's 10z's plus equals 23. So I've just created a new equation without y's in it, so I have equation 4. We need to find another way to eliminate y's. Can't do 1 and 2 again because I've already done 1 and 2. So I can do 1 and 3, or I can do 2 and 3. I want two equations without y. Okay. Definitely seen students in the past that get rid of y once and they get rid of z the next time. That doesn't do you any good. Okay. I want two equations with just x's and z's in them. So I'm going to do 1 and 3 because turning a 1 into a 2 is easy. I'm going to multiply that top equation, though, by +2, so it cancels. So I'm going to take 2 times equation 1. I'm going to add that to equation 3. 2 times equation 1, then add it to equation 3. Those should cancel. And as I go to do that distribution, you just need to be really careful. Take 2 times that, 10x, 2 times that, 2 times that. Make sure you distribute all the way across to the equal sign 2. So 2 times that. I'm bringing equation 3 down as it is, and -3x minus 2y plus 4z equals 3. When I do that, I should have a whole new equation without a y in it. So here I have 7x's. Y's are gone. I have -2z's and -9. So I have two equations that are just x and z. So right there is a problem that we did Monday. All right, two equations, two variables. We should know how to solve that. That's our first goal, right? How do I eliminate one of the variables twice so that we have two equations with two variables rather than three equations with three variables? This problem should be pretty easy to do at this point. Does that make sense? Like how we're shrinking the problem down? You good, Tiger? Good, Ruth? So just like on Monday, right? Should we eliminate the x's or should we eliminate the z's? That's going to be easier. Z's? How are we going to do that, Katie? So we're going to take equation 5 by 5 and add it to 4. Okay, so I'm going to do that over here, so I'm not just running down my paper. So 4 plus 5 times equation 5. Okay, so I'm going to bring it over here. Don't want to change equation 4, so I'm going to make sure I write it over the same way. So negative 13 x's, 10 z's, 23. 5 times this, so 5 times 7, 35. 5 times negative 2, negative 10. 5 times negative 9 would be negative 45. See, our z's are going to cancel. So negative 13 plus 35 is 22 x's. 23 minus 45 is negative 22, which is really good because that's going to divide out evenly. If at any point, guys, you end up with a decimal, just stop, because going any further is just going to give you compound your error, right? You should only have integers here for what we're doing, okay? So you ever get a decimal, you've made a mistake somewhere, really try to go back and see where you dropped your sign, where you misadded, you forgot to distribute. I mean, those are the things you're going to do. It's just going to be little arithmetic errors, transfer errors, things like that, okay? Now that we know x, we're going to go backwards through the problem to find z and then find y. The last thing we got rid of was z, so that's the next thing I can find. The first thing we got rid of was y, so that's the last thing I can find. Let's go backwards. So grab one of these equations over here, 4 or 5, to find z. Doesn't matter which one, okay? Just notice the numbers here on 5 are smaller, so I'm going to use 5. So using equation 5, I'll plug negative 1 in for x. 7 times negative 1 minus 2 times z is negative 9. That's negative 7 minus 2z. 9. So if I add 7 over, I'll get negative 2 here. Divided by negative 2, I'll get 1. So z equals 1. I'm going to use one of the original equations to find y. Right? So find x, go backwards, find z, go backwards, find y. You do have to follow the order that you established earlier. If I just look at this, I see the first equation has a lonely y, so I'm going to use the first equation to find y, not on the other two. So 5 times negative 1, which is x, plus y, minus 3 times 1, which is z. It's supposed to be negative 6. All right, that's a 6. So negative 5 and negative 3 would give me negative 8. So I'm going to add 8 to both sides. So negative 6 plus 8 is 2. So that means I know x and y and z now, I think. So I'm going to write it as an order triple, x, y, z. Okay, so x is first, y is second, z is third. So there's what I think my answer is. I just used equation 1 to find y. I don't really need to check equation 1 again. Obviously, I could have made a mistake in there. I don't really need to check that one again. I have to check the other two. We need to know that this answer works in all 3 equations. Okay? So I'm going to plug those 3 numbers back into here. So in equation 2, 2 times negative 1 plus 3 times 2 plus 1. So that's negative 2 plus 6 plus 1, which is 4 plus 1, which is 5. which is what that set. This set is supposed to equal 5, equals 5. You know it's right. Just because it works for 2 of them does not mean it'll work for all 3. So plugging the numbers back into equation 3, so that would give me positive 3. That's a minus sign, sorry. That's a 4 plus 4. So 3 minus 4 plus 4, those cancel, leaving me with 3. Which is what this is supposed to be equal to, 3. You can see how you could definitely get lost in there pretty easily if you're not being like clear to yourself, clear to somebody else, like where your work is going, not spacing it out in a way that's gonna keep things from getting all over each other. Okay. These are tough because there's so many little interactions that you're doing that it's so easy to make one little mistake and it just will follow you. And you may not know until the very end that you made a mistake. It can be pretty frustrating sometimes too. You're right, 3 times 5 is 8, something like that. It's silly things like that. So just don't rush yourself through it, but just focus on the big idea, right? How do I do this? Knowing what to do and being able to execute it are 2 different things. You need to eliminate one variable twice, and then going through and executing it. Different. Any big concept things you guys want me to make sure I go back over real clearly on the next one? To try it again. Let's try another one. If you guys can lead through this one. Oops. That's a minus sign. X minus 3y minus 2z is negative 3. Okay. 3x plus 2y minus z is 12. And negative x plus minus y plus 4z. So we need to find a way to eliminate one of the variables twice. Why do you want to do that, Maddie? You said equation 3 times 2? What is it? Lost my mouse.
Yeah, because then you'll get negative 2y, which will cancel out the 2y of equation 2.
So you want to get rid of the y's?
Yeah.
Okay. So you want to take, you said equation 3 times 2. Plus equation 2. Okay. Equation 3 times 2 should be negative 2x minus 2y plus 8z equals 6. And equation 2, I should circle that. 3x plus 2y. Okay. This is not what I would have done, but there are many paths through this problem. Anybody see a different path? Yeah, I would have taken advantage of the x's here. That we have a positive x and a negative x. Then we could just those will go ahead and cancel the way they are, and then there's a way to cancel, one of them with the second one also. But they all have a 1, right? So z, there's a 1z here, there's a 1y here. They all have a 1. Just this one has 2 1s, which makes it just a little bit simpler than the other way. So, but yeah, they're all pretty darn easy. So I just haven't done this way yet today, so I'm kind of wanting to do it. I've done it the same way twice in the other one. So yes. So if you want to do equation 1 plus equation 3 right now, you certainly can. If you want to follow this, you can. 1x, that gives me 7z's. That's 18. No matter, we need to do it again. We just can't do it the same way. That's another way we can get rid of y. So you've already set the standard here. We're going to get rid of y, so we need to make sure we do that again. We can't do something different or get rid of something different. So it's a different way to get rid of y. What do you think, Maddie?
You can multiply the first one by 2 and multiply the second one by
3. We certainly could. What I would probably do instead is just multiply the bottom one by -3.
Mm-hmm.
Then we won't have to multiply the top one by anything. So just less interactions would be less chance for us to make a mistake.
Mm-hmm.
If there's a 1, I would always use it to give the best advantage. Multiply the bottom equation by -3. Add it to the top equation. Positive 3x plus 3y, -3 times that would be -12z's. -3 times that would be -9. And then top equation. As it was. Four x's, y's cancel, -14z's. That gives me -12. That's equation 4. That's equation 5. So I have 2 equations without y's. That's good. So Matt, what do you think? How can we get rid of x or get rid of z? You see there we can take advantage of. Okay, how? Thank you. Worked on. Why'd you say z? What'd you notice?
Well, I don't know. I noticed the sign.
Okay. Two votes and what? Which one are you looking at? On the z's? Or somewhere else? You're looking here?
Oh, my God.
Look here, right?
Okay.
The whole point here is to make these the same, right? Or opposites, right? So we found a way to cancel those. Found a way to cancel the y's here. So looking here, can you make these opposites easily, or can you make these opposites easily? Okay. So we need to multiply by to get that to happen. Because they're not the opposite right now, so how can we make them opposites? What do we need to multiply by? I'm going to turn 7 and 14 meant.
Fine, -2.
We don't want it to be negative. We want it to be opposite. We want it to be positive.
Oh, okay. Just do it.
So 2 times 4 plus 5. So 2 times that is 2x plus 14z. 2 times 18 is 36. 4x is over minus 14z's minus 12. 6x equals 24, which again is a good sign because that's going to divide out evenly. X equals 4. Again, if you get any decimal there, stop and be wasting your time continuing. So try to figure out where you made a mistake. So since we found x, find z next, since that's the last thing we eliminated was z. So plugging back into one of these, it doesn't matter. See the numbers here are smaller, so I'm going to use equation 4 to find z. 4 plus 7 z equals 18. So subtracting 4 over 7z equals 14, so z must be 2. X, there's z, so then back to one of the original equations and find y. I'll just use the bottom equation, number 3. So -4 minus y plus 4 times 2 equals 3. So -4 and 8 would have to be 4. Subtracting 4 over would give me -1. Negative y equals -1, which means y is 1. I think the answer is 4, 1, 2. There's my order triple. I just used equation 3, so that means I need to check equations 1 and 2 in order to make sure it actually works in all 3. So 4 that's 3 times 1. That's 2 times 2. That's 4 minus 3 minus 4. Now 4 minus 4 is 0, minus 3 would be -3, which is what that says, -3. Check. 3 times 4 plus 2 times 1 minus 2. That's 12 plus 2 minus 2. So 12 plus 2 minus 2 is 12, which is what that says, 12. That was our correct answer. So again, big idea, right? How do we take 3 equations, 3 variables, rewrite them as 2 equations, 2 variables, which we can then rewrite as 1 equation with 1 variable, right? Shrink, shrink, okay? Keeping track of things as you're going through it so it doesn't get messy worse than it already is, okay? Anything? Not many neurons? Talk to you guys about how to apply this to application, right? Real life stuff. So you've taken this, we're going to be extending this into matrices here in a little bit, tomorrow or Thursday or whatever, but we got to start applying that to the word problem first before we can do that. Good, Ruth. Good, Victoria. You So I have a word problem. I don't want to write down the whole thing like word for word, so I'm just going to kind of hit the highlights on the wording. So just this is gonna be one of those. You've got 70 coins in your pocket, and pennies and dimes and nickels, and they add up to $4.33, and there's 12 more pennies than dimes, like type problem, like how many of each. So it's just Like those types of problems are like, you're buying 100 flowers, daisies and roses and petunias, and these cost this much and these cost this much, and you spent $250, and how many of each did you buy? Like those types of questions, or what we use this type of math for. So you have a total of 20 coins. And it's going to be quarters, nickels, and dimes. A total of 20 coins, quarters, nickels, and dimes. The value of all is $1.90. So I had a student last hour that was struggling because they were able to they made a guess, and they were able to guess correctly, and then see, well, why do we have to do all this other stuff? Well, this is a pretty small problem. Right? As soon as you start getting numbers bigger, you can't guess anymore. So we're just focusing on a small problem right now. So not that we're going to get to big numbers, but just focus on the process. And then you have 4 times as many nickels as quarters. So you have 4 times as many nickels as quarters. The question is, how many of each do you have? Okay. How many of each? In the end, we'll be able to say we have this many quarters, we have this many nickels, we have this many dimes. That's where our answer should look. But we're going to have to set up equations. In order to have equations, we have to have variables. And so in order to have variables, we need to say what they stand for. When you are talking about word problems and using letters to represent things, you really need to be very clear about what those letters stand for. Okay? So as basic as this seems, if you don't do this, you're going to find yourself in a world of hurt. You need to define your variables. You get to pick what letters you use, but you need to say what they stand for. So you've got to define your variables. Okay? I can use X and Y and Z. I can use A, B, and C. I can use Q, N, and D. Doesn't matter. But I need to say what they represent. You need to be more specific. You can't just say X equals quarters. You need to say what is it about the quarters you're trying to find? What is it about the dimes, about the nickels you're trying to find? You need to be clear on that. Okay? To me, to yourself, to whoever, really to yourself, what are you trying to find? So go back to the question. Okay? You pick your letters. Okay? I'm going to use X, Y, and Z. You pick the order of what they represent. Okay? But if the first thing I see is them asking about quarters, that's just the first thing I want to write down. Okay? I want to rearrange it and put the smallest thing first, and you put the smallest thing first. It's up to you. You need to be clear. And what do they want to know about the quarters? They want to know how many there are. So that's what my variable needs to represent. Okay? If you just put quarters and you're not sure what you're actually finding, context gets lost, and it's not really good for you. So the number of quarters is what I'm trying to find. The amount of the quarters, the quantity of the quarters, right? The number of them. That's what I want to know. Not how much are they worth, how many there are. Okay? It's the same thing. I'm just going to order. So that's the next thing it said was nickels. So that's the next thing I'm going to write down. So I'm going to be my Y's, I'm going to be my nickels. And the last thing it said was dimes. So that's going to be my last variable. Okay? You guys get to decide all of that. What letters you're using, what order they're in, but you don't get to decide what they stand for. You need to say what they stand for, but that's been decided. You need to make sure you're reading that and getting that down here. You get to pick the order, you get to pick the letters. You don't get to pick this. You make sure you're interpreting it right, though. Okay? So, number of. Okay? Now this one's pretty simple in the way it's laid out. And it's very nicely laid out because essentially each sentence is its own equation. It's not always that clear. Okay? But especially with like a lot of this stuff, deals with money. So you have purely like a count thing. So how many coins are there, or how many flowers are there, or if you're buying like a large quantity of nuts, like you buy 50 pounds of nuts, and then there's cashews and walnuts and pecans, and then each one has its own price. Like there's an amount you're buying, but then there's also a value or a cost to all the things you're buying, right? Or here's the value of or worth of all the coins. So there's an amount, which is completely separate from the value. How many coins do I have versus how much they're all worth? Those are two separate equations. So when I'm talking about counting, that's just a number plus a number plus a number is another number. X plus Y plus Z is 20. Okay, if I have 5 of these and 10 of these and then 5 of those, that would give me 20. It has nothing to do with how much they're worth, just how many there are. So I have a quantity equation. Okay? It's purely just counting. How many are there? But coins also have value, or other things that we buy have value, how much we pay for them. Okay? Now I can start talking about that. I take the value of all my quarters plus the value of all my nickels plus the value of all my dimes, then I get the total value of my money. We have a problem here, though. When we talk about quarters, nickels, and dime, we often think of cents, 25 cents, 5 cents, 10 cents. This is in dollars. Can't do both at the same time. So my equation needs to be all cents or all dollars. So if I want to say this in dollars, that's $0.25. That's $0.05, not 0.5. Right? That's $0.10. So do I want decimals to keep it in dollars, or do I want to go in cents and make my numbers bigger? Well, I'd rather not have decimals. I'm going to go to cents. But you have to be consistent. 25 cents times my quarters plus the value of my nickels, which is 5 times how many nickels I have, plus the value of my dimes, which is 10 times how many dimes I have, will give me the value in cents. Okay, so that's 190 cents. So just make sure you're being consistent, whatever it is. Okay. The last one is usually the hardest for people to wrap their heads around. The easiest equation, right? It's also the easiest one to mess up. There's usually like some sort of relationship equation. Okay? You've got 4 times as many quarters as nickels. You bought 50 more roses than petunias. Like some sort of relationship between 2 of the values. Okay. Notice it doesn't say anything about dimes in that sentence. It's saying here's the quarters, here's the nickels, compare them. Right? See the word times, right? You can see the word less, you can see the word more. And of course, less means subtract, more means add. Okay? We know that there's some sort of multiplication, right? And our natural instinct would say, well, it says 4 times the number of nickels is the quarters, right? Well, nickels is y, quarters is x, so 4y equals x. Okay. Does that make sense? You guys should all be able to read that sentence and say, are there more nickels or are there more quarters? When you read that sentence, are there more nickels or are there more quarters? More nickels. So should I take a bigger number and multiply it by 4 and get a smaller number? Yeah, doesn't make sense, right? No way that can be right. 4 times a bigger number can't be a small number. Well, what's the possible way we could rearrange it, right? 4x equals y, right? Big number, right? 4 times a small number equals a big number. Okay, that makes sense. But see how easy that is to mess up, especially because the way we talk and the way we math don't agree. Okay? And this happens pretty much all the time. If I say I'm 20 years older than you, don't add 20 years to my age, even though the 20 was next to me in the sentence, add 20 to your age, right? I'm 3 times older than you. You don't multiply my age by 3, multiply your age by 3. Like this the way we talk, the way the math interacts, is usually backwards. Okay? So I really suggest you guys, you need a way to judge your equation. Because if you write the wrong equation, you can solve that system correctly. It's not going to be the right answer because it's not the wrong equation. Okay? You need a way to stop and judge that. Is this correct? So I just talked to you guys about one way. Just purely read it and say, which of these numbers is bigger? So, and that number's bigger, and go back and say 4 times big number equals little number. Oh, not good. The other way is a little bit trickier, okay? Is you could just throw a number at it. You've got to be careful about the number you pick. If you pick the wrong number, it'll be hard to figure out. So how do you know what number to pick? It says you have to have 4 times as many nickels as quarters. Your number needs to have a 4 in it. Okay? So if I say, well, there's 4 times as many nickels as quarters and you have 3 nickels, there's no way to figure that out. Okay? If I say there's 4 times as many nickels as quarters and you have 20 nickels, there's 4 times as many nickels as quarters and there's 20 nickels, what do the quarters have to be? 5, right? Well, is 4 times 25? Nope. Is 4 times 5 20? Yep. So you can see if it works, right? But you have to pick the right type of number. So just make sure that you're kind of looking at that. So it can be tricky to pick that number. But I think you guys should all be able to do the bigger versus smaller. Which of these is bigger, which of these is smaller, and then go back and compare. Should I be adding 3 to this, or should I be adding 3 to the other one? Okay? You've got to stop and think. This is where all your energy should be, guys. If you don't do this correctly, there's no way to do the rest correctly. What's actually nice about this, the math here is so much simpler than the math that we just did on the last 2. Because of this. This equation only has 2 variables in it, and one of them is already solved for. Okay? You need to take advantage of that to make everything else so much simpler. But if you screw up that equation, it's just all for naught. Okay? Anything you guys want to talk about as far as like writing the equations before we move on to solving? Who's blowing up their eardrums right now? Okay. Been there, done that. Okay. So earlier we were talking about like don't use substitution because it's not usually easy to get rid of one of the get a variable by itself. Variable by itself right there. Take advantage of that. Substitute the heck out of that thing. Okay? You can rewrite both of these equations without a y in it right now. X plus 4x plus z equals 20. Okay, there's no more y. 25x plus 5 times 4x plus 10z equals 190. Okay. 2 equations, no y, really fast. We got 5x's plus z. This is by any means not the only way to do this, guys. There's plenty of ways to do this. It's just a way to do this. Got 25x's plus 20x's. That's 45x's plus 10z's equals 190. Okay. That was really easy to get to that step compared to what we were just doing on the other 2. Okay. Does it make sense how I took advantage of that 3rd equation to get here quickly? Okay. Looking at these 2, say, can I get those to be opposites? Oh yeah, I can get that to be a 45 pretty easily. Multiply that by -9. I could also get this to be -10 really easily. I'd rather multiply by 10 than 9. Less likely to make a mistake, right? I think multiplying by 10 is easier. Really just preference at that point. I'm going to multiply this by -10. I'm just going to bring it down here below. That way it's already stacked. I don't have to rewrite the whole problem twice. I'll multiply that top equation by -10 and bring it down here. I'm going to add it to the middle equation. Negative 50x minus 10z equals negative 200. Z's will cancel, giving negative 5x equals negative 10. Which means that x is 2. Or what x stood for, number of quarters. If you ever get a decimal or a negative or even 0 here, something went wrong. I can't have 0 quarters. I can't have decimal quarters. I can't have negative quarters. And you're only allowed to get natural numbers on these problems. You get a decimal, you get a negative, you get 0. Something went wrong. Gotta figure it out. But we now, right? And we know what x is. Well, look what. There's y. Y is 4x. I can find that out really easy. Y equals 4 times 2, which is 8. Now I know x, now I know y. Use one of these two equations to find z. We all agree the first one's easiest. 2 plus 8 plus something is 20. Of course, that's 10, so z must be 10 also. So we found values for all 3 variables. We better make sure it works, though. Okay. We've already used equation 3 right here. We used equation 3 already, so we don't need to check that one again. We just used equation 1. We don't need to check that again. The only thing we haven't used yet is equation 2. So we need to make sure these actually add up to be $1.90. Yeah, I've seen plenty of students that have done this, and then you go back and you add up their coins. They don't add up to the amount it said it was supposed to. Or you go back. I've had students that do it the other way around, and then they go back and you count but you have more than 20 coins. It's not the problem. Okay? You need to make sure it actually meets all 3 criteria. Do you have 20 coins? Do they have $1.90? Are there 4 times as many quarters or nickels as quarters? Right? Does it meet all 3 criteria? Okay, not worry on time. It will. Okay, it does check out. I just want you guys to make sure you write your answer. Okay, 2 quarters, 8 nickels, 10 dimes. Just write your answer with some words in it. Okay, just like I've always asked you guys to do on word problems. Okay. You guys have the worksheet in your Google class, visit at home, okay? Try those out, see how they're doing. All right, bring me your work tomorrow, make sure it's working out for you. Okay? Help you find your mistakes if you're making any.
Thank you.
See you guys, bye Ruth. Take care.